welcome to the January 2015 Regents exam in chemistry. This is a walkthrough of Part A. You're now looking at question number 1 on the screen. According to the modern model of the atom, the nucleus of an atom is surrounded by one or more, and they give you 4 choices. All 4 of the choices represent particles that are frequently discussed in chemistry. Now, the basic concept of the atom includes the nucleus, consisting of positively charged protons and neutral neutrons. The nucleus is surrounded by orbiting electrons, and that is going to be answer number 1. A positron, answer number 3, is a particle emitted by a radioactive atomic particle during nuclear decay. That's going to be further discussed in topic 12. Question number 2. Which particle has a mass of approximately 1 atomic mass unit? If we examine the particles that they're offering us here, an alpha particle, a beta particle, an electron, and a neutron, the alpha particle and the beta particle are both particles that are involved in nuclear chemistry, which is topic 12. This question is about basic atomic structure, so we're really going to choose between the electron and the neutron. I've included a table over here which shows the basic structure of the subatomic particles proton, neutron, and electron. We're looking for the particle that has the mass of 1 atomic mass unit. So that would be one of these 2 particles, either the proton or the neutron. The proton is not offered as an answer, so we're going to stick with the neutron, answer number 4. Question number 3 from the atomic structure topic. A specific amount of energy is emitted when excited electrons in an atom in a sample of an element return to the ground state. This emitted energy can be used to determine the... Now, if you look through the answers, you'll notice answer number 1, answer number 2, and answer number 4 all refer to quantities of the sample, the mass, the volume, and the number of moles. Those are quantity-dependent answers. The only thing you're really going to be able to tell by looking at the emission spectra, which is what is produced when an element returns to its ground state electron configuration, is the identity of the element. It's going to be answer number 3. Question number 4. According to the wave mechanical model, an orbital is defined as the... So we're looking for the definition of the term orbital. That's really what this question is about. Orbitals are the locations where you can most probably find electrons, not neutrons. Okay, so since answers 2 and 4 both refer to neutrons, we can eliminate them. And it's the most probable location of the electrons, not necessarily a defined circular path for the electrons. Here's some support material that explains that a little bit. And you can see that the orbital is defined in this particular text as the most probable location of an electron. So that's going to be answer number 3. Question 5. All phosphorus atoms have the same. Now, they could have substituted in place of phosphorus. They could use really any element in that position, and the answer is going to come out the same, because our basic understanding of the atom includes the idea that all atoms of a particular element have exactly the same number of positive charges in their nuclei. In other words, same number of protons. And since the number of protons is, in fact, equal to the atomic number, the answer to this question is going to be 1. Mass number can vary because we can alter the number of neutrons in the nucleus. The number of neutrons plus the number of electrons, well, of course, if you're altering the number of neutrons, you're going to be altering the sum of neutrons and electrons together. And of course, the same can be said of the sum of neutrons and protons together. Since we can change the number of neutrons, answers 3 and 4 make no sense. Question number 6. At STP, which element is a good conductor of electricity? You're given 4 elements to choose from here. The background information we need to know is that metals are good conductors of electricity and nonmetals are bad conductors of electricity. So all we need to do is determine which of these 4 elements is the metal and which of the others are nonmetals. I've taken the liberty of placing the 4 elements on this little mock-up periodic table. You can see the locations of sulfur, chlorine, and iodine are all within the confines of the non-metal zone. And over here, all by itself, is our silver atom. It is a metal. That makes it a conductor of electricity, and that makes the answer to your question 3. Question 7. Which phrase describes the molecular structure and properties of 2 solid forms of carbon, diamond and graphite? Having 2 different forms of the same element is what we refer to as having allotropes of that element. I've included a table that shows an example of oxygen allotropes, oxygen O2 and ozone O3. They're both composed of oxygen, so they are the same element, but they have different molecular structures. One has 2 oxygens, the other has 3. You can see that on this chart, which shows 4 different properties of these 2 allotropes of oxygen, that every single one of the properties is different for the 2 allotropes. So we're looking for an answer that describes having different molecular structures and different properties. That's going to be answer number 4. Question 8. Which quantity is equal to 1 mole of gold? Symbol Au. To answer this question, you need to know precisely what a mole is. A mole is a quantity equal to 6.02 times 10 to the 23rd particles of something. The relationship between the mole and what we see in the boxes on the periodic table is that the mass values on the periodic table, here for gold we see 196.967, this mass value represents the mass in grams that you would need in order to have 6.02 times 10 to the 23rd atoms of that element. So in other words, the quantity equal to 1 mole of gold is equal to the atomic mass in grams. Answer number 1. Question 9. Given the balanced equation representing the reaction between methane and oxygen, according to this equation, what is the mole ratio of oxygen to methane? We're working here with a balanced equation, and we're asked to find the mole ratio. Well, recall from balanced equations that the coefficients that you find in front of each of the items in your equation represent the mole ratio for that equation. There's an example that I've included in this screen where we have a balanced equation that shows 2 compounds reacting to form 2 products. And here you see a ratio of 2, 7, 4, and 6. So the ratio is 2 to 7 to 4 to 6. So if you alter any one of these numbers, the others will adjust accordingly and proportionately to reflect that same proportion. So in other words, if you double the first item to 4, you have to double all the other items, and so forth. So coming back to our question, we're asked to find the ratio of oxygen to methane. Well, the oxygen has a 2 in front of it. The methane has no number in front of it, which means 1. So our ratio is 2 to 1, and we're talking about moles, not grams. So we have to cross out the answers that are using grams in the answer, and we're looking for a 2 to 1 ratio of oxygen to methane, and answer number 4 does that very precisely. Number 10. Which list includes 3 types of chemical reactions? Recall from your knowledge of chemistry that there are essentially 4 types of chemical reactions in inorganic chemistry: the synthesis, the decomposition, the single replacement, and the double replacement. There's a decoy among these answers that you'll notice, and here it is, the word solidification. Solidification is not one of the basic forms of chemical reactions. In fact, solidification is the process of changing a liquid into a solid. So it not being a chemical reaction, we can eliminate all the answers that contain the word solidification, leaving us with answer number 2. Question 11. Which compound has the greatest percent composition by mass of sulfur? Well, you'll notice all 4 of these compounds contain sulfur. So if sulfur is going to have the greatest composition by mass, it needs to be combined with the smallest or lightest element. So all we're really doing in this question is comparing the barium, the calcium, magnesium, and the strontium to see which has the smallest mass. I've included a clip from the periodic table that shows all of these elements in the same column of the periodic table. And we will locate each of them. Here's the barium, here's the calcium, here's the magnesium, here's the strontium. Magnesium has the smallest mass, and that would give sulfur the greatest percent composition in answer number 3. Question 12. 2 molecules of HBr collide and then form H2 and Br2 during the collision. The bonds in the HBr molecule are. Well, to analyze this question, I first wrote out the equation that shows the reaction taking place. We're starting with HBr, and we're winding up with H2 and Br2. So the first thing that has to happen is that the bonds between the H and the Br must be broken. Breaking chemical bonds requires an input of energy. That's an endothermic process. In other words, it absorbs energy. So we are breaking bonds and absorbing energy. We're eliminating answers 3 and 4 because here they're claiming that bonds are formed. They're not. They're being broken. And energy is being absorbed. So we're breaking bonds, absorbing energy. Answer 1. Question 13. Which atom in the ground state has a stable electron configuration? What is a stable electron configuration? Well, if you're a very small atom like helium, a stable electron configuration would just be having 2 electrons in the first energy level, because that's all the first energy level can hold. But if you're a larger atom, like for example a neon atom, we're trying to fill the second energy level with 8 electrons. So having a stable octet, that's what makes you stable. So we're going to compare these 4 atoms, and all we really need to do is check to see which one of them already has 8 valence electrons. You can see that neon is the winner, as it has 8 valence electrons. The last number in this sequence is 8. Oxygen's a 6, magnesium's a 2, carbon is a 4. So neon is your element that is already stable because it has a complete octet in its valence electron shell. Question 14. Which statement describes a multiple covalent bond? Well, what is a covalent bond? In this image we can see examples of covalent bonds. The first image shows a bond between 2 hydrogen atoms. Notice that the bond involves 2 electrons. So each covalent bond is represented by 2 electrons. If we're looking for a multiple covalent bond, then we need at least 4 electrons for a double bond. And we are sharing, not transferring. That would be ionic. So 4 electrons are shared. Answer number 2. That would be an example of a multiple covalent bond. Question 15. The electronegativity difference between the atoms in a molecule of HCl can be used to determine what? I've put a clip here from our review book. The electronegativity difference between the atoms in the bond is shown here as a range going from 0 to very large. What does this affect? It affects the ionic character of the bond, or inversely, the covalent character of the bond. If the electronegativity difference is 0, we have a nonpolar covalent bond. As that electronegativity difference grows, the degree of polarity increases, and we even would wind up with an ionic bond if that difference becomes too large. So what we're really using the electronegativity difference for is to determine the polarity of the bond between the 2 atoms. And that's all you can use it for in this case. That's answer number 4. Question 16. Which 2 gases cannot be broken down by chemical means? Recall that elements are the types of substances, pure substances, that cannot be broken down by chemical means. We're going to instantly select answer 3 because it's the only answer that is comprised of elements only. So we are going to choose answer 3. Notice that response number 1, response number 2, and response number 4 all include compounds, and compounds indeed can be broken down by chemical means. Question 17. 2 substances in a mixture differ in density and particle size. These properties can be used to do what? Recall that there are many different ways you can separate the components of a mixture. These are called separation methods. Here are just a few. Filtration, which relies on the particle size, distillation, which relies on the boiling points of the different components, and chromatography, which relies on absorption rate. So separating the components of a mixture is directly dependent on what properties those components of the mixture have. This is answer number 1. Question 18. Which unit is used to express an amount of thermal energy? Here you simply have to know what these different words mean and what they're related to. The gram is a measurement of mass. The mole is a measurement of quantity. We discussed a little bit earlier. The pascal is a measurement of pressure. And the joule, of course, is a way that we measure energy. Answer 3. Number 19. Under which conditions of temperature and pressure does a real gas behave most like an ideal gas? An ideal gas consists of particles which are free to move about randomly. The more space they can occupy, the more able they're going to be to move about randomly. They also don't want to demonstrate any attraction between each other. So the conditions that would favor this most likely would be a condition of high temperature, so that the particles can move faster. And we also want to decrease the pressure. Decreasing the pressure would be the effect of making the container bigger, and that's going to allow the particles to spread out to a greater extent. So we're looking for high temperature, low pressure. That's your ideal gas condition. Question 20. According to the kinetic molecular theory for an ideal gas, all gas particles, read number 1, are in random, constant, straight-line motion. That's the first thing we learn about the kinetic molecular theory. Looking through the other decoy answers, are separated by very small distances? No. We want very large distances between the particles. Have strong intermolecular forces? Nope. We want them to have weak intermolecular forces. Have collisions that decrease the total energy of the system? No. We don't want to lose any energy through the collisions of the particles. Number 21. Which mathematical expression represents the heat of reaction for a chemical reaction? Let's quickly examine a couple of potential energy diagrams that we pulled out of our text. You can see the potential energy diagram always begins with your reactants. We go through a transition, and then we end up with products. The heat of the reaction is the difference between where you start and where you end, shown here by interval number 5. Since that interval in this case is a negative value, you can see that we're going to need a negative numerical value to represent it. So our delta H, we're going to have to start with the products and subtract from it the reactant energy in order to get the actual delta H. The answer that corresponds with that is number 3. It's the potential energy of the products minus the potential energy of the reactants. Answers 1 and 2 are really bad decoys here because they're not even talking about this unit, potential energy diagram. They're talking about heat of fusion, heat of vaporization. Those are phase changes, not even involved here. And number 4 is just the opposite of the correct answer. Number 22. At 101.3 kilopascals and 298 Kelvin, a 1 mole sample of which compound will absorb the greatest amount of heat as the entire sample dissolves in water? You need to be aware that there's a reference table that will give you the answer to this very easily. It's table I in your reference tables, which shows the heats of reaction. Several of these reactions involve the dissolving of solid substances in water. I've highlighted a couple of those here, including our 4 potential answers. Since we're looking for the one that will absorb the greatest amount of heat, we need one that has a positive delta H value. So as we look over the delta H values provided on table I, the most positive one we see is right here, positive 14.78. That's associated with the ammonium chloride. Ammonium chloride will be our answer. Number 23. For a reaction at equilibrium, which change can increase the rates of the forward and reverse reactions? And we're given a whole bunch of different changes that are going to take place. And again, we want to know which one is going to change both the forward and reverse reactions by increasing them. So let's analyze our 4 answers. If we decrease the concentration of the reactant, we'll take a look at this sample potential energy diagram. If we decrease the concentration of the reactant, that's going to enable the reaction to move more to the left, less to the right. So that's not an equal increase of the rate of the reaction. Decreasing the surface area of just the products, well, that's going to favor one direction over the other, not both. An increase in temperature. If you increase the temperature of the system, all the particles will move faster, so any collisions you're discussing are going to happen more frequently. That's going to speed everything up. 3 is our answer. The 4th potential answer here, an increase in activation energy of the forward reaction. I've drawn a little potential energy diagram for this potential reaction. The green arrow represents the forward activation energy. Raising that to a higher level certainly isn't going to speed anything up. So we're going to stick with our answer number 3. Number 24, which reaction produces ethanol? Well, I've taken the liberty of writing out each of the 4 different reactions being discussed here and just giving you a quick review of what they represent. Combustion reactions involve the production of carbon dioxide and water plus lots of energy. Esterification reactions are methods for producing esters from alcohols and acids, and water is also a product. Fermentation, that's how we get alcohol. That's your correct answer. And polymerization produces polymers and sometimes water. So we're going to stick with answer number 3, fermentation. Number 25, the chemical process in which electrons are gained by an atom or an ion is called. Well, first, let's get rid of 2 of these answers. Addition and substitution are 2 concepts that come out of the organic chemistry unit, and they are methods for linking halogens to hydrocarbons. So let's get rid of them, 1 and 4. That leaves us with oxidation and reduction. Well, the gaining of electrons is one of those 2 words. How are you going to remember which is which? Hopefully you've learned to say, Leo says ger. The gaining of electrons, ger, is called reduction. Answer 3. 26. Which process occurs in an operating voltaic cell? Please recall that the voltaic cell is the one that operates spontaneously. You put the chemicals together in the right configuration and then close the circuit, and you're going to have the spontaneous flow of electricity through the system. The electricity comes out as a result of an oxidation-reduction chemical reaction. So we are actually converting chemical energy into electrical energy, answer 2. What's wrong with 3 and 4 is that they've reversed the processes. Remember this little phrase, red cat. Reduction is the process that takes place at the cathode in your electrochemical cell. So these two have been reversed, makes them the wrong answer. And number 1 is just the opposite of the correct answer, which is 2. Question 27. What can be explained by the Arrhenius theory? The Arrhenius theory is an acid and base theory which suggests that acids donate hydrogen ions to solutions when they are dissolved. Note that it is a theory that comes from the acid and base unit of this course, number 1. Answers 2, 3, and 4 are all relating to different topic areas: equilibrium, electrochemistry, and nuclear chemistry. All the wrong answers. We're going to stick with number 1. Number 28. According to one acid-base theory, a water molecule acts as an acid when the molecule does what? Well, there are 2 theories. One of them is required by name in the Regents curriculum. That's the Arrhenius theory, which states that acids produce hydrogen ions in solution and bases produce hydroxide ions in solution. The other theory, which is never mentioned by name on the Regents exam but is usually referred to as one acid-base theory, suggests that acids are donators of protons and bases are acceptors of protons. So if we look back through the answers, we see that donates a hydrogen ion as being the best answer here, because it is associated with acids. Certainly, acids are not associated with donating hydroxide or anything to do with hydroxide, and they don't accept hydrogen ions, they donate them. Answer 1. Question 29. Positrons and beta particles have... This is a question from the nuclear chemistry unit. So I will throw up a chart here of various nuclear particles. And if we highlight the positrons and beta particles, we'll be able to compare them on the basis of mass, charge, symbol, and penetrating power. Here we're being asked to consider their charge. Is it the same or is it different? Well, the beta particles -1, the positrons +1, so they are truly different. Eliminate answers 1 and 2. And now in terms of their masses, they have effectively no mass. They're the size of an electron. So their masses are indeed the same. So we need different charges with the same mass. That's going to be answer 3. And finally, question 30. Which term identifies a type of nuclear reaction? Okay, we're looking for a nuclear reaction. That's going to be number 1, the transmutation, which of course can be either natural transmutation or artificial transmutation. To make sure you don't fall into the traps of the decoys, we've isolated each decoy item here and identified it. Neutralization, that's a process involving a reaction between acids and bases. Deposition is the transition from a gas to a solid, comes from the physical properties unit. And reduction is the reduction part of oxidation reduction, from another topic as well. So we're going to stay with answer number 1. And that concludes our first 30 questions on the January 2015 Regents exam. Look for additional videos that cover the rest of this exam. Again, thanks for watching. Look for additional videos from alchemtutor.com. For questions, comments, or permissions, please contact me at asnyder@alchemtutor.com. If you have interest in contracting tutorial services from my company, you can also contact me through the website at alchemtutor.com.